We've been using radicals a little bit already, but now we're going to learn how to perform some operations with those. And by operations, we mean sums and differences, so adding, subtracting, and products or quotients, so multiplying or dividing. So we can use properties of real numbers to perform those operations with what we call radical expressions, just any expression that involves a radical. For example, we can use the distributive property if we want to simplify sums or differences of radical expressions by combining their like radicals. And by like radicals, we mean radicals like 3 rad 5 or 7 rad 5 if they have the same radicand. Again, radicand means that number inside the radical sign. Unlike radicals, such as 4 rad 3 or negative 2 rad 2, those would have different radicands. So just like if I have unlike terms or like terms, I can combine like terms, but I can't combine unlike terms. So trying to simplify a few of these, 6 rad 11 plus 9 rad 11, since those both have the same term inside the radical, they both have 11, I know that I can combine the 6 and the 9, so that makes 15 rad 11. Same with our other few. Again, if I just have nothing written outside your radical sign, you want to remember that as like an invisible 1, just as a placeholder. So if I have rad 3 minus 5 rad 3, that becomes 1 minus 5, and then I can just simplify that as negative 4 rad 3. Same thing if I have 7 rad 2 minus 8 rad 2, I can combine the 7 and the 8, and the rad 2 is just going to stay. So 7 minus 8 would just be negative 1, or I can just write negative rad 2. Last one, same idea, 5 rad 5 plus 2 rad 5. Those are like radicals, so I can combine that and get 7 rad 5. We may also, though, need to simplify our radical expressions first to determine if they can be added or subtracted by combining those like radicals like we did before. So we didn't have to simplify any of those last radicals because those were already all in simplified form. But if I look at these next practice set here, that first example, 5 rad 3 minus the square root of 12, that means that square root of 3 and square root of 12, I can't combine those at first. Those don't look like radicals. But if I simplify the square root of 12, since that contains a perfect square, square root of 12 would be the same as writing square root of 4 times the square root of 3. So if 4 is a perfect square, I can simplify that part as just 2. So if I take that first term, 5 rad 3, and I've simplified the square root of 12 to be 2 rad 3, now I can combine them as like radicals, 5 rad 3 minus 2 rad 3. I can just subtract the 5 and the 2 and end up with 3 rad 3. Again, I'm just going to subtract the coefficient, and the radical part is just going to stay the same. So same thing on the next question, 4 rad 7 plus 2 rad 28. At first they don't look like like radicals. So I'm going to have to simplify the square root of 28. And since that contains a perfect square, square root of 4 would just be 2. I can simplify the square root of 28 as just 2 rad 7. Again, the rad 7 part is just going to stay because we can't simplify that any further. So if I combine 4 rad 7 plus 2 rad 7, 4 and the 2 combined to just make 6 rad 7. Last question, let's see if we can do this same idea again. Square root of 32, I have the square root of 16 as a factor of that. So square root of 16 is a perfect square. That would be 4 rad 2. So if I simplify a square root of 32 as 4 rad 2, I'm also going to do the same thing with the square root of 18. Since that contains another perfect square factor, I can factor that out as 3 instead of square root of 9. And now if I still have those coefficients in front, so still a 5 and still a 4, as long as I simplify the radical expression, now I should still be able to combine these. So 5 times 4 rad 2 would be 20 rad 2. 5 times 4 I multiply and the rad 2 stays the same. And same thing with the 4. 4 times 3 I multiply. The rad 2 I'm just going to leave by itself because I wasn't multiplying by another radical. So if I have 20 rad 2 minus 12 rad 2, 20 minus 12 would give me 8, so 8 rad 2. And if I want to simplify a product like rad 10 times the quantity rad 6 plus 3, I can use the distributive property to multiply rad 10 times rad 6 and also rad 10 times 3. So this is just where you have to use that same rule that we've used before. If I have a number written on the outside of parentheses, I'm going to multiply the first term but also multiply the second term. If both factors in the product have 2 terms, so instead of just one number on the outside of those parentheses, now I have what I call 2 binomials. So rad 6 minus 2 rad 3, but also multiply the quantity rad 6 plus rad 3. I can use the FOIL method to multiply just as when we did when we were multiplying binomials. And just to go over FOIL again, the F in FOIL stands for first term, so rad 6 times rad 6. Then I'll have the outside terms, that's the O, rad 6 times rad 3. Inside terms, negative 2 rad 3 times rad 6. And last terms, negative 2 rad 3 times rad 3. And we'll see that what that looks like on that last practice question there. But first, if we want to find all these simplified forms in the first part, just like that first situation where I want to use the distributive property, so if I just make sure that I'm multiplying the rad2 times the rad6, and also the rad2 times the 5, we'll see what we get from both of those. I should get rad2 times rad6 would make rad12, and rad2 times 5 would just be 5 rad2. Again, since they're not both radicals, I just have the 5 stay as a coefficient, and the rad2 is not going to be affected. One more thing, though, is that we have to simplify the square root of 12. That's not in simplified form because 12 should contain a perfect square factor. And since that perfect square factor is 4, I can factor the square root of 4 as just 2. So instead of square root of 12, I would have 2 rad 3. But if I still can't combine those terms, these are both simplified but still not like radicals, that's just going to be my final answer. So that's my simplified form. Again, 2 rad 3 plus 5 rad 2. The radicals don't match, so I'm just going to have to leave that as is. Next question, first thing you might want to do is rewrite that. If I have the quantity square root of 11 minus 2 and that quantity is squared, then since I have a squared factor, that just means I'm multiplying the same thing twice. So I'm taking square root of 11 minus 2, square root of 11 minus 2, and multiplying. And this is where we're just going to use foiling. Again, foiling means I multiply the first terms, so square root of 11 times the square root of 11. That would just give me 11. When I multiply one radical times that same radical, basically all that happens is my radical sign is canceled out. Now if I do the outside terms, square root of 11 times negative 2 would be negative 2 rad 11. And then if I'm doing inside terms, same thing, negative 2 times rad 11 would just be negative 2 rad 11. And if I'm doing the last terms, negative 2 times negative 2 would be a positive 4. Gotta watch out for those two negative signs canceling out and becoming positive. So now this is my expanded form of that. It looks like these two in the middle are like radicals. I have the square root of 11 on both. And I also have two constants. I have 11 at the end, or sorry, at the very beginning, and 4 at the very end. So if I add 11 plus 4, those are my like terms, I get 15. If my like radicals, negative 2 rad 11 minus 2 more, I get negative 4 rad 11. So that would be my final answer, and that's our simplified form. So last question is pretty much starting off from what we did on the previous one. I still have to do foiling if I have two binomials. So again, foiling means I do rad 6 times 4 rad 3, and I just left that as is here. And then for our outside terms, rad 6 times 3 rad 6, so multiply that here. Inside terms, negative 2 rad 3 times 4 rad 3. And then for our last terms, we have negative 2 rad 3 times 3 rad 6. So just make sure, you can take a step just writing all that out just to keep track of what is being multiplied together. Because then that makes our next step a little easier. If we're multiplying this as our first terms, all I'm doing is multiplying rad 3 times rad 6. The 4 is the only constant, or sorry, the coefficient. So the 4 is going to stay. Rad 3 times rad 6 would just make rad 18. So let's say that's 4 rad 18 for now. And next thing, next term, I have 3 and then rad 6 times rad 6. Remember all that happens there. If I multiply the same radical, is that the radical part cancels out. I just get 6. Same thing happens on our next term. 2 times 4, though, on the outside is going to be 8. And then since we have rad 3 times rad 3, that part will just be 3. And for your last term, I multiply 2 times 3 for my coefficient. And rad 3 times rad 6 is rad 18, just like it was in that first term. So since I have the square root of 18 as my only radical, I want to make sure we can simplify that. So square root of 18, since 9 is a perfect square factor, I want to simplify that as 3. And then I'm also left with a rad 2. So if I rewrite square root of 18 as 3 rad 2, it looks like I have that in the first term. I also have that in the last term. And I also took this step to simplify the two inside parts. So 3 times 6 is 18, and 8 times 3 is negative 24. And then it looks like I just want to multiply my radicals out. So 4 times 3 rad 2. I multiply the 4 times 3 and just get 12, and the rad 2 will stay. I also simplified 18 minus 24 to be negative 6. And for my last term, I can multiply negative 6 times 3 and get negative 18, and that square root of 2 will also stay. So one more step is to combine my like radical expressions. I have rad 2, so 12 minus 18 would be negative 6 rad 2, and I also still have that minus 6. So that would be my simplest form of that answer. So last page here is talking about conjugates, which is the sum and difference of the same two terms. Doesn't have to be radicals, but we're going to use that for radicals here. So for example, rad 7 plus rad 3 and rad 7 minus rad 3 are conjugates. because it's the sum and the difference of the same two terms, rad7 and rad3. So the product of conjugates, if I multiply those two together, would end up being a difference of squares. And you can think of that with FOILing. I would have first terms multiplied is rad7 times rad7, so that's rad7 squared. Outside terms, I would have a negative rad21. Inside terms, I'd have a positive rad21, so those would cancel. And then for my last terms, I would have rad3 times rad3 being multiplied. So if I want to simplify all that, basically all that's going to simplify to is 7 minus 3, and that's just going to give me 4. So that's a really easy way to get rid of some radicals, is to multiply a conjugate. So the product of the conjugates we see has no radicals in it. We can use conjugates to simplify a quotient whose denominator is a sum or difference of radicals. And it's going to make these a lot easier if we can just use conjugates rather than trying to simplify each one by itself. So for example, if I have 10 over the quantity rad7 minus rad2, if I'm trying to use that conjugate, I'm going to still use rad7 and still use rad2, except instead of subtracting, I'm going to add those together. And if I want to multiply on the bottom, cancel it out. Also have to remember I can't do that unless I multiply the same thing on the numerator as well. So if I multiply the numerator, 10 times rad7 is just 10 rad7, but I also have to remember to distribute, so 10 times rad2 is 10 rad2. And for the bottom, we don't even really have to write the work out, we just have to remember that when I multiply conjugates together, that's just going to be a difference of their squares. So rad7 is just going to make that a 7, and rad2 just going to end up being 2. So if I multiply those two together, I just end up with 7 minus 2. And if I simplify the denominator, 7 minus 2 would just give me 5. And last step here is just to divide the 5 out of both my terms. 10 rad7 divide the 5 out, I end up with 2 rad7. 10 rad2 divided by 5, I just get 2 rad2. So same thing on the next one. If I have rad10 plus rad5 as my denominator, I want to simplify that. So the conjugate would be rad10 minus rad5 instead of adding. And again, multiplying across the top, negative 3 rad10, but also watch out for that negative sign. Negative 3 times negative rad5 is a positive 3 rad5. And then remember, if it's conjugates, I'm just going to end up with 10 minus 5 for the bottom. So if I just simplify that bottom part to be 5, I can't do anything with the numerator, and that would be in simplified form. So make sure you get some practice with this, and I'll see how we're doing when we come back.